Hello students, how are you? Hope you are doing well. Now I am reading the question. 10 capacitors, each of capacitance 1 microfarad are connected in parallel to a source of 100 volts. The total energy stored in the system is equal to option A 10 to the power minus 2 joules, option B 10 to the power minus 3 joules, option C 0.5 into 10 to the power minus 3 joules, and option D 5 into 10 to the power minus 2 joules. So the problem is based on the concept of energy in a capacitor. To calculate the energy in the capacitor, we have to use certain formulas. For example, E equals to half CV square. This is one of the formula. Similarly, by using the relation Q equals to CV, we can find out two more formulas. For example, if we want to replace C by Q and V, then C equals to Q upon V. It means that E equals to half of Q upon V into V square, which is equal to half Q into V. This is the second formula for the energy. Similarly, we can express the formula in terms of Q and C. For example, if we want to eliminate V, it implies that V equals to Q upon C. So we can say that E equals to half multiplied by C multiplied by Q upon C whole square, which is equals to Q square upon 2C. So out of these three formulae, we can use any according to the given problem. Now in this particular problem, we have 10 capacitors of same capacitance, and these are placed in parallel to each other. So there are total of 10 capacitors, capacitor 1, capacitor 2, and up to capacitor 10. All of them are having a capacitance of 1 microfarad. This is the capacitance of a single capacitor. These are connected in parallel with a source, with a DC source of 100 volt. 100 volt fixed source, it means it is a DC source. So 100 volt. In parallel, we know that in the parallel, the voltage remains same. So we can say that the voltage is 100 volt for each and every capacitor. Now the basic concept is there are 10 capacitors. We have to calculate the total energy of the system. It means that if we calculate the energy of one capacitor and multiply it by 10, we get the overall energy of the system. So the energy of any single capacitor is given by half CV square. Now half C is given as 1 microfarad. It means that 1 into 10 to the power minus 6 farads multiplied by the value of V. The value of V is 100 and it's square. So we get this value as half multiplied by 10 to the power minus 6 multiplied by 10 to the power 4. So this value comes out to be 0.5 multiplied by 10 to the power minus 2 joules. So this is the energy of a single capacitor, and we have to calculate the overall energy. So the overall energy, that means the total energy of the system, is 10 times this energy in a single capacitor. So this value comes out to be 10 multiplied by 0.5 into 10 to the power minus 2 joules. So this value comes out to be 5 into 10 to the power minus 2 joules. So 5 into 10 to the power minus joule is the total energy of the system, which is given in the option D. So option D is the correct option. So hope you understand this problem.